I'll just start. So I'll just let that down in the background. All right, so, okay, beginning Haskell. So this is iascala user group, and I'm talking about Haskell, which is like talking about cousin. So it's kind of like a family reunion, I guess. So what is a Haskell? According to like their front page, this is what it's an advanced, purely functional programming language, an open source product with more than 20 years of cutting edge research, allows rapid development, robust, concise, correct software. That's not too far off. It's just not really marketing speak, I guess. So the way I kind of think about it is, I don't know where I read this. It might have been Learning Haskell or somewhere else. You kind of compare Haskell to like a spaceship, an alien spaceship, and everything else is just kind of like planes and trains, right? Where when you try to get into it, it's all these different knobs, it's all these different things that you really don't know how to really understand. But once you understand it, like you can really fucking fly. So I kind of think of it as that metaphor. To me, it's a different way of thinking about things, but at the same token, it's like an alien artifact that once you fully grasp on it, it's extremely productive. So I started with Haskell, I don't know, probably shortly after I started with Skull about 4 or 5 years ago. And I started with learning Haskell and just kind of got turned off by the language. And I don't exactly remember why. It's probably something stupid. And then I just kind of didn't do anything with it for a long time until about a year or so ago. And then it was, I kept on running all these blog posts, all these things now, whereas all this Haskell syntax is talking about all these different things, and I just didn't understand it. So I set out to learn Haskell. Do that. And that's why I started learning Haskell. It's been a long, long trail, and I still feel like there's still like lots and lots and lots to learn. So that's why this talk's called Beginning Haskell, because this should get you set up to learn how to study Haskell, more so than actually learn Haskell. I could probably very few people on this earth that really know Haskell. It's just like a tower, a mountain. So once you get over one little mountain, here's another giant mountain right beside it. So why Haskell? Why might you guys want to learn Haskell? Like, you guys came here. You guys hope to learn from Haskell. Anybody? You guys want to know how it compares with Scala? It's an easy one, right?
How to be a better Scala developer.
How does it make you a better Scala developer, or how a better developer in general? Why? I mean, other things you might think of like, is it really that academic? Is it really practical to use? Is there? I mean, we're all pretty good programmers. I consider all that. And you're always trying to further your skills. So Haskell's a great way to start. So begin motivational quotes real. There's a lot of quotes I have about Haskell, like languages in general. Like, this is Benjamin Lee Whorf. He's a linguist. How many of you have heard of the Saber Whorf? Yeah, he's the Whorf part of that. But it's language shapes the way we think and determines what we think about. And I find this really true with a lot of different programming languages that I've learned from my career or my life. The limits of my language mean the limits of my world. That's another good quote. Language that does affect the way you think about programming is not worth knowing. This is from Alan Perlis, great computer scientist. And a lot of the newer programming languages I see come up, Go, Rust, I'm like, okay, what are really advantages they have? And I read the little bylines. They're great stats for the industry is large, but they don't really challenge you to learn anything new. They're safe ways to work. This is another good quote. That really kind of like capstoned it for me for how I think about Haskell, and what the big fundamental shift for me was. The more context I need to understand things, the more wrong they're likely to be. And that's why I don't use globals, and that's why I use functional programming. This is applicable in Scala as well too, a little bit, but I kind of think of it as, oh, damn it, this is a post there. Don't worry about that. It's kind of like this unlearning part. I know the slides out of order there. Damn it, the images are all broken. I don't know who we were talking to somebody or interviewing somebody, and they talk about axiomatic reasoning, and really this is like the great unlearning of a lot of what I've had to do in Haskell, where I write something and I tell it to do something. In the back of my mind, I was still thinking about, okay, this does this, this does this, this does this, all the way down the line. And for me, it's a principle of trust, in that now I can fully trust that that's really working there. I really just need to stop thinking about that stuff and start really thinking about just the signatures themselves and working my way through that. And that was like the big fundamental shift for me. That's why I don't have to know any context about anything. I just need to know, okay, here's what I got. I need to make this do this. I glue this into this. Make the signatures all kind of match up together. And I don't really have to think about, okay, when I'm folding over things, there's something in the background and reading over it. Like in the case of actors, like ask. Like when I ask something, there's a lot like an actor ref underneath that. I just really don't have to think about that. Types themselves give me context around what it's doing. And it just kind of works. I don't know. I mean, how many of you kind of feel like you've gotten anything like that in programming in the past? Or you all still kind of think that you're still thinking of the underpinnings of a lot of things when you actually work through things? That's really hard for me to. That was like a shift that took me a long, long time to get over. Okay, so how many of you know a little bit of Haskell, or can identify Haskell if I like throw it out here real quick? All right, good. So I'm going to just kind of go over some of the properties of Haskell, and then I'm going to go over how to like gotchas, like starting Haskell development a little bit. This properties of Haskell will go for a little bit, but this will be like, here's how you write a function, here's how you do all the stuff. And there's a lot of core unique things that Haskell does that other languages don't have. I'm kind of go through that stuff too. But. All right, so syntax, really simple. I mean, how many of you know how to write 2 + 2, right? And parentheses still gonna matter, right? The way you call functions, though, is very different. So Haskell, all you have are values, really, and you have functions that act on values. That's all you really have when you're actually writing code. There's types too, so it's like a value and type. I'll get into that later. Well, when you want to add things together, when you want to call a function with arguments, call the function in space, first argument, the second argument. Really, nothing else to that. White space does matter. It is a little white space, like Python a little bit. But it's not nearly as strict as Python, but it's weirder in different ways. We'll get into that when we're writing functions. But that's all you really have to know. This is all the Haskell syntax is. Everything else is like that. There's inline functions. This plus is a function. This add is a function. Parentheses add scoping. What more do you ask for? It's not like Lisp where you have parentheses after parentheses, which that is a good advantage itself because then you actually have a well-defined tree, but it'll kind of work. Within the infix functions, there is like ordering, and you can tell it to be right associative or left associative. I'm not going to worry about that. Did this thing finish? Sweet. Put this up. Within GHC, there's this GHCI, the interactive thing. It's really like the bee's knees. But okay, so what I was going to show you, you still have like your simple control structure. You have if and else. If I don't even need parentheses. I'm so used to them as Haskell. 3 equals greater than 5, then 1, else 0. 3 is not greater than 5. So the same thing. I wonder if I can view this. Sorry, 1 second. Can't remember. You can also do this is where the scoping actually matters, like the white space matters. When I do like an if like this, underneath of that, there's just a new scope, so that has to be indented somehow underneath of that. What did I do? Oh man, mess that up. Probably missing from my laptop. Like this is all in Emacs. Last, I mean, you still got everything else is pretty simple, right? You got lists. Lists are really kind of important about any language that we work with, and they're pretty important in Haskell. I mean, these. All there is to a list is like it's a simple linked list. That's all. I mean, you remember what a linked list is on sides. You got a middle, they got cons, which is something up top in front of it. And it just kind of keeps on building on that. That's what they are in Haskell. But there's idiosyncrasies too, because Haskell's also lazy. So when you actually ask for its tail or something, right? It doesn't have to give it to you right away. When you ask for its head, it doesn't really have to give it to you right like that. I'm going to talk about laziness here in a little bit. But to construct a list, it's just like that. 1, 2, 3, or whatever. You can cat list together. I'm going to try and 1 second. We don't really use. What? Sorry, I'm trying to get a better way to do this. A few seconds. I made the slides to make myself get on track. Okay. So to cat list together, let's say down there. Pretty easy. Right? To construct a list, to cons a list. Like that. I put on 1 onto front of 1, 2, 3. Same thing. Think about this cons thing. It's a lazy operation as well too. Everything is lazy until you really want to be strict or anything like that. There are some things that are strict. I'll talk about this thing a little bit more later too. Enumeration. So in Scala we have ranges. In Ruby we have ranges. And Haskell, since everything's lazy, it doesn't really have to worry about that. All it has to worry about is what you're giving me, can I iterate it? Can I find the next element on it? So when I go 1, 10, that gives me back 1, 2, 3, 4, all the way up to 10, right? Then I can say 1, 3, just get odds. That, give it like a step. Be able to do that. I'm able to give it just a list that goes on forever. If I write this, what do you think it's going to do? You guys will blow up. It'll just keep on printing out numbers. The thing I'll talk about numbers here a little bit too soon. But they're big integers by default, and they'll just keep on going and going and going. And you can which you'll see how to interrupt it. But we got up to almost 1 million, right? A million numbers printed that fast. Um, since Haskell's lazy, right? It doesn't have to fully figure out that infinite list, right? What ends up happening is when we ask it to print, when we ask the list to print itself, it's like, okay, what's your, and it's like, okay, I know my list, so here's my first bracket, right? And it's like, okay, what's my first elements? What's my commas? So it prints that up, then it puts out a comma. And then since we're in enumeration, it's like, okay, what's the next one after one? It just keeps on doing that. It's just this loop that just does it over and over and over again. Pretty cool. There's a lot of things that are enumerable. We'll talk about that here in a bit too. But characters are enumerable. I'll kind of talk about why it shows up as a string there in a little bit. But yeah, cool, eh? You have the usual suspects. You got your head. You got your tail. You got take, which is kind of cool. I mean, take 3, right? Your net, your last, you can reverse a list. Okay, but one thing to notice. So in the back of your mind, you really don't have to think too much about Haskell's laziness, and this is like an unlearning thing that I have to think about. It's like when I do a take of the list, take 100 out of the list of infinite list, right? I used to think, okay, well, I'm gonna have an infinite list, so it's gonna like try to figure that out, and then it'll blow up. So you don't really think that way. You're like, okay, I'm just gonna take 100 out of this list, and it just works. That's kind of cool. You get your map, your filters, your fold lefts. What do you got? Okay. I'll talk more about mapping here when I get to higher order functions. There's some new ones since we're like have infinite lists. We can cycle through things. If your closures do the same thing, I think too. Cycle exactly the same thing. If you repeat something, repeating 1, right? You can replicate 5, whatever, how many 5A's, and then iterate, which iterates just like applying the function on something over and over and over and over again. You guys ever do like what is that thing? Like the programming challenges where there's like 100 things. What is that called? What? What is it? Rosetta code? Maybe it is Rosetta code. There's like a whole bunch of like lists, pretty much lists. Like find the first one's like find the first all primes over a certain number.
99 Scala.
It's 99 Scala, which is based on something else. I started to do it a long time ago and then just lost interest in it using Haskell. What is it? Yeah. Project Euler, yeah. A lot of them use if you do all the Haskell stuff, you'll be using a lot of these cycle, repeat, replicates, and folding. I don't know. Outside of that, I don't really use them that much. You got your tuples. You guys know what a tuple is. Scala. 1, 2. Oops. 1, 2. You can mix them up like this. They, I don't know how big they can get in Haskell though. I don't think there's like any arbitrary like 29. Find out. What's easier? Copy paste. Okay. Max size is 62.
You didn't have number 1.
What?
So you do an extra column.
Oh yeah, I was fine with that. Really? Okay, well, it's 2 different things. 101 tuples too large for EHC. But you know, this is like the first thing I really like about Haskell. You'll find out is this error messages really do help you. It'll tell you what the fuck is wrong with your code and how to fix it. Workaround: use nested tuples or define a data type. Instead of like in Scala where it's like barf, here's your compilation error. Yeah, it's where it's totally obtuse. there are some nice. Put off here. I mean, to get the first of a tuples like that, it only works on pairs. Second, I think that's all about the only ones they really have. When you do pattern matching, which I'll talk about in a bit, you can use that a little bit more. Cool. You got your booleans, you got true, you got false. Same things, same way. The other way, they work the same way other things work. True and false, and then or. Nothing special there, right? So string. How many know how Scala implements implements string as an array of characters underneath of it? You know how you can do like list over it and stuff like that? It's really a hack underneath how it interacts with the collections library. Make strings, rich strings, and can build froms. Haskell cleans that all up. Is like, you know what? Strings are just characters. I mean, that's all they really are. Haskell supports Unicode out of the blocks too. It doesn't support functions unless there's like a switch you can turn that on. But so like when you do this, that's an empty string. But it knows. It knows a little bit of magic of like that I'm supposed to show an array of characters has quotes around it instead of like the normal list. This is the same thing. That's true. If I do A, B, C like that, it shows up as ABC. Show you the replicate thing there. Lines, kind of cool to do. Oops. Just kind of strips and splits. Yeah, there. One thing, there is ways. So in Haskell, when I type hello like that, there are what's called language extension. There's one for what's called overloaded strings. So when I type something like that, then it knows based on whatever I'm passing into what type that should be. And same thing is true for numbers. So how many of you in Java, any other language really, when you type in a number, like and it really wants a long, it's like, oh, numeric widening or some kind of junk like that, right? So in Haskell, since it's got types and it's got this great recurrence thing, it's like when you type in 5, you really don't have to tell me what it's going to be. I'll figure it out for you based off of whatever types going down the road. And what it defines it in terms of, and there's actual values for those. There's like an int, there's an int 16, there's an int 64, there's an integer, which is like the big int. It's Java, there's doubles, there's shorts. I don't know if you really even uses shorts. There's bytes, which calls word aids. But when you type 5 like this, if I do type 5, what is the type of 5? What do you think it's going to tell me?
Integer.
You think it's going to say integer? It's going to say, I don't know, until you actually pass it to something. But it's going to say, I can tell you it's numeric. So this is the first thing we're going to see in type classes here. Way to think of it as a constraint. It's like, this 5, I can tell you it's numeric in nature. You can add it to things. I'll show you out its implementation later whenever you actually pass it to something. But this is the constraint on it. It can add things, it can be divided by things. Do 5.0, it's fractional, which is another type class, which means it can be divided. There's more methods on fractional than there are. You can now divide it. That has to be numeric. Okay, I'll talk about this later. I'm getting ahead of myself. Go away. But that's something cool, which is I had never really been exposed to it before. It's like, well, what type do you want this to be? Do you want to be long? Do you want to be a double or anything like that? you just pass in 5 and or whatever, and kind of like one of the first things I noticed where I feel like what I'm writing and the idea that I'm expressing are two distinct things, and Haskell's kind of like bridging the gap between that. When I write down things, it's doing a lot of work on its side to figure out what I'm really thinking. All right, functions. All right, so what would be a functional programming language without functions? I've waited all this time to tell you guys about functions. And then how to call them. They're pretty easy to call. You got type signature and implementation. Type signatures are optional. So you've noticed so far I've only showed you I've showed you no types. I've not shown you other than that little T thing, right? You don't have to have them. By convention, it's a really smart idea to do it. It'll infer a lot of things for you, but sometimes what it infers might be too generic for your needs, and it just leads to things being a little bit obtuse. You got your let in. So one other thing too is in a lot of other languages you have multi-statement functions where you say let do this, do this, do this. In Haskell it has to be one statement function, but you can do bindings to things. So I can say instead of doing like a val x equals 1, val y equals 2, I can say let x equal 1, let y equal 1 in, and then this is the one statement I want to run. There's a where. Which is also kind of like a let. There's semantically kind of the same thing. There's like some really small difference between the two of them that you never really run into. It's just kind of like a matter of preference of. Sometimes what you'll do in Haskell, you'll have this little helper function within a function, where you're accumulating something, or you're doing something recursive. And I'll usually use a where in that instance where I don't want to have to do a let defining a function. I would define that function in a where. We'll see some more of that as we go. All right. Next cool thing. Haskell's pattern matching. So when you write a function, let's just do one that adds 2 numbers. So some in GHC I have to do. Yeah, I do. Yeah, I do. Let me see. I don't remember how to do this one out. Yeah, I have to do a let add in here. Normally in GHC, I don't have to call let. I can just say add xy equals xy. And I do add 2, 3, 5. You notice I didn't put any signature for that or anything like that. I can do it like this. I think. Maybe not. Yeah, okay. That sucks. There. But you can pattern match in functions. The arguments functions, or in Haskell, or not in Haskell, Scala, you have to do a case. You have a match and then do a case on it. In Haskell, you can just say, you just match on it in the arguments, and it just works. You can pattern match on data objects and new types. I'll kind of show you what those guys are. I'm going to get ahead of myself. But for a pair like this, 1 AB or 1, 2, if I want to get the first out of there, let first AB. My first takes in type 1, type 2, gives me T. I'm going to use some nano. Nano has? Nah, of course. you want to run just a Haskell script and without compiling it or anything like that, you just say run Haskell. Don't worry about that. I know what it's compiling about. So I don't actually call anything in it. If we do 1, 2, and 3 like this. What did I do? Okay, I'll just load it for you to see it first. So when we do a first like this, going back to my first function here, wow, either. This kind of goes back to this axiomatic reasoning that I think about. Just by going by the signature here, there's only one thing that thing can do. What do you think? What else will this thing do, right? I have some type A, right? I have some type B, right? I pick a pair of those, right? I'm going to give you a type of A. I don't know anything else about that type of A. It's just like I have to give you back an A, right? So the only place that this function really can get it from is from there. That's like a very simple way of looking at it, but I mean there are functions you can't reason that way, like reverse. By taking a list of A's and returning a list of A's, right? What all could that thing do? It could not potentially reverse it. It could give me back an empty list. It could give me back the head of a list, or just like how many arbitrary elements out of that list, or a whole different. Can't give me a whole different list. So there are catches with that, but I don't know. That's kind of that's what the types really help you out, and that you're really not. The more parametric. This is a paper called Theorems for Free, which Philip Bradley came out with like 30 years ago, almost 30 years ago. But where he talks about a lot, what he talks about in it is this concept of the more parametric you make an actual function type, the more understandable it is. It seems kind of obtuse, but where I can just look at the signature and know what it does. This is what a lot of work has been done since then. I don't really do that. Higher order functions. To pass in a function, it's the same type of thing. I need a function from A to A that then takes in another A and returns me an A. I'll kind of talk a little bit more about why these functions are this way. Flip, if I take an A, B, that returns me a C, that's what my function here does. I can return you a function that takes a B and an A and a C. So like apply twice would be pretty simple. Taking an F, we're taking an A, right? We want to return F, F, A. You're pretty good at now. Sorry. I'm going to do apply twice. Just add one. It's this. Give me 3. I'll talk a little bit while we'll do that too. Yeah. Any questions so far on the type signatures? Yeah.
So, just backing up a little bit, you talked about pattern matching. You had that example first.
Yep.
And you said that it can only return A.
Yeah.
You contrasted that with reverse, which takes an A and returns an A.
Takes in a list of A's and returns
a list of A's. Okay.
Right.
But in first, Oh, okay, maybe I see it now. In first, we don't know the type of A or B.
Right.
So A could be a list,
Totally could be a list.
and first could return that. Why couldn't the A that is returning be that list reversed?
Because when I'm writing this function, I can't know that. All I know is I have some type A. I don't know I'm getting a list of A. I can't. If I was to write like just the pattern match like on like this, and return to you like just like this. Oops.
You're saying you don't need an implementation of that.
I do.
Oh, you do. Okay.
I do. I'm just saying, but there's only one possible implementation of that. I can't do like this. I can't say, okay, I'm going to pattern match on some. This is where it kind of differs from Scala, where Scala can pattern match. The case statement can be any type. On this, is to make sure that whatever this is right here has to be a subtype of A, or in some way. If I try to compile that, if I try to load that up in GHCI, it's gonna be like, what? Oh, fine. It's gonna be like, couldn't match expected type A with actual type, length of integer. A is a rigid type variable bound by type signature of blah, A, B, to A. The pattern here, the pattern there, and the equational there. What it's basically saying is like, I can't pattern match on an array. I have to pattern match on something of A, which I don't know. So I only can say, the only thing I can do is A.
And if the definition above it was the A was in brackets, then you could have done what you had before, right?
Yeah, totally. I could do it like this. But I still have to return you some type of A. And the only way you really can do that, to tell you the truth, it's like that.
Because the right side is.
Right. I don't really even care. You can use underscores by convention. It's just used to mean I don't care about it. But that's the only way I can get an A out of a list of names. Sorry. Now it's fine. But if I give it like first an empty list like that, it'll blow up because heads is not safe. Right? That's something they've been willing to change for a long time. But, okay. Where was I at before all that? Higher order functions. Yeah, just kind of talk about that. Parentheses, the type of the function that you want. So all there is to it. Anonymous functions are a little weird. I'll give you that. Let's add to. Basically, where in Scala you have this, actually, yeah, give its type, this, too. This is the same thing. But the way they use this to mean, like, use parentheses, and they use this little backslash, because it looks like a lambda, I guess it did back in the day. And then whatever variable bindings you have, and then dash greater than your body, right? That's the same thing. This dash over here is what they use to comment, whereas like in Scala it's slash Ruby's outside. But I can still call it just like any other function. It's the exact same thing as defining it otherwise. But it's smart. It's difficult to know that, like, oh, you're adding 2. I don't know why I know why zoom in, but I can't do any of the constraints or that. I mean, you can use that a little bit. I mean, if you do like the map, right? How many you guys all know what a Scala map is, right? You take a list of something and you apply something to each element, it returns you a list of all those elements changed. Same thing here. List two. The thing about it, and you'll see this a lot in Haskell, is compared to how Scala puts its arguments, like the function's always last. In Haskell, the function's always the first argument. And the reason for that is because of this, which just imagine like a self-partial application. What do the functions look like? This guy, what do they look like? Int and then int to an int. Why did they do that instead of two ints? The truth of the matter is, in Haskell, functions only take one argument, and the reason for that is so that they're always curried. So I don't have to supply all the arguments here. Really, what this is saying is like, you give me an int, I'm going to give you a function of int, right? You give me two ints, you give me an int first, right? So I give you back a function of int to int. And then you give that guy an int, then you're going to get your final int. You can show this, like do add. So what is our type of add, right? Int, right? What is our type of add? And then let's do 9, right? So I'm given 9 as a first argument as add. What do you guys think the type is? Yep, that is. It's add into int. And then if I do int into 0 or 10, right? That's where I finally get my int. So I actually can do things like add 2 equals add 2. And then I do add 2 and 3. The type of add 2 is just an int to int. So you really don't use anonymous functions nearly as much as you do in Scala. You do them in a different sense. Like instead of, let's do like, let's do add 10, right? It's going to take an int, it's going to return an int. X equals, just for fun, you're going to add 10. I don't even have to define this, just add 10 like this. But what I'm going to do is, what you typically do, you do a where, and you're to find any helper functions or anything like that. I didn't do that. But what I was getting at is like, I don't even need to give this guy even an argument. I don't have to do add x, then add 10 to x like that. I could just say, just drop it as all off. Because my add 10 is going to be an int to int, right? And my add 10 gives me, this is int to int. It's already given one int. It's going to give me my function int to int. You'll see this. This is a way this gets more sophisticated. It's called point-free programming, where you basically are chaining together functions and composing them together, flipping things around to relate. And this is why I think in Haskell you don't see many like long variable names either. You see really good documentations for method names and function names, and you see not so really long functions either. But what you'll see is like instead of like a long variable name, just like how the flow really simple goes together. At least that's been my experience with that. Yeah, I mean, going on. I mean, we want to do take 5, take some list of A, and returns your list of A, right? And take 5 is take. Do you remember take from earlier, right? taking them 5. Okay. Recursion, I'm not going to spend a whole lot of time on this. In Haskell, it's tail recursive. You still do have a stack, though. I mean, you can still blow the stack. There is, let's see. There is, so as part of this, there's a fold. I mean, you know what a fold is in Scala, right? You take your first element, you apply something to it, you take the second one, apply it, pass it in, all the way. And you go from the left all the way to the right. In Haskell, I don't even know, I think in Scala, I don't know if you do this or not. In Scala, or in Haskell, it's easy to like blow the stack and do anything like that. If you have a list of 1,000 elements, or whatever, 20,000 elements, what does it doesn't matter, right? It can run a stack space. So, well, not stack space, but it'll end up having it just holds a pointer to a holds a pointer, keeps on doing this, so you can run this heap, run up a heap. So because of the laziness of it, because it's not evaluating things that is going on, it's called a space leak. But then there is a oops. To combat that, there's this fold L dot. Oh man. Which is a strict version of that same signature. Nobody ever uses the fold L. I don't know why it's in the preludes, like the default still, but anyways, I don't really want to do that too much. So let's look at some good functions here. This is your quick sort algorithm. This is what they show like on the Haskell front page. It's like really slick. How many know what quick sort is? Sort stuff. Take something out of it, compare everything to it that's smaller than it, put on its left side, everything else on the back end. So in quick sort, you take this. This is an ORD. Right? This is a constraint, like how we had that enum earlier. The same means that two things are comparable for order. We take a list of A and those things. Empty list, you don't have to do anything; it's already sorted. Well, then we take in, we pattern match on this P XS. It's like even the first element of XS. Since we've already had a first pattern here that the empty array, just take our pivot, put in the quick sort feat, and then the rest of the list, just kind of uncons them, and then we're going to quick sort everything that's less, and then we're going to cat it with our pivot, and then quick sort everything greater. And where lesser is filtering out everything that's less out of that, greater is filtering out greater than or equal to. That's really all quick sort is, right? Pretty nice and easy to read. Factorial. I mean, factorial is pretty easy. One is 1 factorial n. Well, yeah, there's an n. Let me cheat a little bit. N times. Just back the bottom all the way down. Yes, I know this is not a total function because if I was less than 1, it's going to miss 1. So, or I could actually do that. Say factorial n where n is less than 1. I think we covered that with error. So just using pattern matching and just recursing over everything. Easy, right? Somebody want to like walk me through like how do you write a reverse? Yeah. So what would we want to do first? We want to get the last element, all right? Then whatever's delete. Okay. Take this like steps. We know that this is the easiest one that we know, right? Reversing the empty list to the empty list, right? Reversing something with something in it, right? So we have our head and then the rest of it. Means then that we need to reverse excess, and then we need to add on our x to that end. Really, all of this is pretty simple there. Let's try that out. It works. That's cool. Zipping things together. So what do we want to do at first? If one of those is empty, right? Say this one's empty. We don't care about the second one. We're done there. Second one's empty, same thing. Let's say we have something in both of them. That means we need to just, we have that, take out the first two, console those together, and then zip the rest of it together until one of those is empty. There you go, guys. My nano skills are getting awesome.
I sense a change of paradigm.
Yeah, if I just become a give up Emacs for it. So now I'm going to zip together some list starting at A, some range, and then 1, 2, 3. Oh, did I not load it? Man, that was going to be awesome.
This runs around the how much?
Wait, you're right. I didn't do this. What did you?
This shouldn't be.
No, I was going to see what I wanted to see what the GSC said. Can I match expected type A with actual type? I gave it a pair for the first argument. The pattern here. So really, yeah, this is all wrong here. My bad. Like that, right? There we go. A, B, and C. All right. So length. I want to do all of these. Let's just do max. Real quick. X prime. X and Y. Let's say X is greater than Y. Right. We say then X is our max there, right? Another thing you can do is you can do this otherwise, like this. Otherwise, it's Y. This is another way you can use pattern matching. Say, give me these two, then your guard, X greater than Y, and then you can give another guard for it. You're just so that's cool. All right. Anyways, this is about functions. Any questions about functions? There's mine. They're really succinct and pretty nice once you get really used to it. You kind of running you for dealing with functions in other languages. Those comprehensions are kind of like for comprehensions in Scala, or they're more like in Python, I'd say, by default. A few other cool stuff with it. I don't really use them that often, but you guys know how to use them in Scala. It's the same way. Haskell, more or less. You can say x plus 2, and then you feed in x 2, you get x, feed in 2 and 10. One thing I didn't mention earlier, maybe I should have, is that you can take up any function and make it inline just by putting backticks around it. So you'll see it like mod, like the modulo division, right? 10 mod x equals 0. Anything that's divisible by x. You can combine two lists together. This is just like just as it is in Haskell. Taking a file from A to H, or from A1 to H, you got a whole chessboard. Cool stuff. All right, types. All right, we've kind of seen a lot of types. But how do you make your own types? A couple different ways. There's data, which is you name your type and then all the different constructors of that type. So where in Scala you can say I have a trait and it's open-ended, or I can have a sealed trait and here's all the types of that, or objects of those. It's kind of similar to a sealed trait. Like I say I have a metric unit. I can't instantiate a metric unit, but I know I have values of meter, a liter, and kilogram, and I can't. There's no way to construct those other than saying meter, a liter, and kilogram. But I also have this data name, which has the same value constructors with the same thing, and it takes in a string and a string. So going here, if I do, what is our type of name? This value constructor here basically creates a function underlying that, given two strings, string and string, returns me a type of name. Let's do the So what is my type of metric unit? What do you guys think this will do? It won't do anything. There's like, what I'm asking it is, what is the type of a type? That's a weird thing to ask. If I ask it, what is the type of meter? It's like, oh, meter is a metric unit. I can just call it meter. Don't worry about this. Okay, same way. It's not that. I can't print that out. So that's how you can construct your own data. There's also another way called moving here called new type. So let's say I have I use this a little bit. It's like where I have a long ID for a primary key, but I will make sure that that's the only. This table's primary key is only a specific type of long. Does that make sense? And within Scala, those are called tag types. Shapeless uses them. I don't know if anything else really uses them. Scala Z has some stuff for it. But in Haskell, it's like you get a part of the language, and they encourage you to use them instead of doing like type. You can also type aliases of say record ID. Instead of doing type like that, which is a type alias, I would do record ID. Like, oh, it's an int. Instead of that, what they encourage you to use is new type. And what this does is like kind of a way of subclassing it, kind of use from the OOP standpoint, without any cost or anything like that. So I can say record ID int. Oops. And now Because we only have a type of record ID. Underneath the covers, it'll actually there's no performance cost. But anyways, okay, gotta keep on moving. So that name thing that we had earlier, it's kind of sucks that if I want to get like the first name of something, like I have to pattern match against it all the time, and I have to know what position it is, and I can't actually refer to it by anything. Within Haskell, there's a record syntax too. We're gonna do first name, last name, and now I do name. That. Hand waving. His name, Luke, last name, Amdor, and I'm going to do first name, first name, this. On a slide, real quick, I almost wrote this a different way using this funky thing. You'll see a lot of Haskell code use this. This $sign is a function itself, and it's kind of a trick where it has in the infix operators. This has like the lowest priority of everything, which means everything on the right gets done evaluated first. Just takes in your function here, and then takes in your value there, which you can be. Instead of, it's basically a way to get around writing parentheses. What you'll find in like Haskell code is you'll read a lot of code from right to left instead of from left to right, just because of that. Yeah. So like when I did this earlier without deriving anything, I said name, Luke, Amdor, right? It's like there's no instance of show, aside from music print. There's no instant declaration of show name. This is basically Haskell saying, you gave me something of name, right? And JCAI lets me to print that out, right? Which is what this print it means. But it's like Haskell's like, I don't know how to show that. So one of the things we've gotten really used to, and coming from, especially from a Java background, is that object has toString on it. I always will be able to show you what the string representation of something is. In Haskell, it does it by default. But they made things really easy. So a lot of these things it's able to automatically derive based off of like, you have two strings here. You have, like Lincoln Skulls, like you have a case class. It automatically makes a nice little one. Haskell's a little bit nicer. You have to say derive and show, and oh, now I know how to show that. It just figures it out for you. Smart. Also, like if I do Trent here, it's like, oh, I don't know how to equalize those guys. And you add another deriving. And so, like, I know how to equate a first name. I know how to equate a string, which is my first name. I want to equate a last name, which is my second string. So I should be able to automatically derive that, right? And it is. I got the same person. Good deal. Type parameters, like, how do I explain this? So in Scala, your option type like is generic over A, right? That's how you do it in Haskell. There's no covariance or contravariance by default. Everything's invariant like that. I already talked about this. This is going to outline. So these shows and queues, they're kind of like an interface. If you work with Banner, you know what an implicit type class is. We use those quite a bit. Haskell just has this as first class support. It's a way of saying, I guess in Clojure you have protocols as well, which is what the they're based off of type classes. This just means like, here's an interface of something, right? I'm not going to give you any action. I can give you an implementation of it by default, but I can't tell you what all instances have that. It's up to those things that own those instances in a way, like of writing their own interface for those actual implementation of that. I kind of think of these things just as constraints. So I'm not gonna. That's all I'm really going to talk about type classes. Like you get an ORD type class. Talk about it. You have things to order. Do that. Enumerable type class. Enumerating things. You got a num type class. Already got that. EQ type class. Quality. Show for actually taking something and putting it into a string. You see how many things implement show. You can do info on any type class. And I'll show you all instances of those that are in scope. And there's not a whole lot. A lot of tuples. An instance declaration of something can also say that it has a constraint on something else. If I'm showing off an array of something, I need to be able to know that I can show whatever's inside of that. Just a whole bunch of EQ, it's about the same. So, and those are all based off of your scope, and your scope's built based off of modules. So when I did this -m data list, that's a module. There is a module up there called data list. And in that module, there's all these functions. And I can just do data list here. Browse. Those are all the functions that are in there. So not everything has to be exposed within a module. It's very simple. Like you have a module, you define here. If I go up to the top, not everything's required to have a module. Although if something doesn't have a module, it assumes that the module's name is main. Scratch. Where. And then everything that falls after that is in the Scratch module. And I'm pretty sure that in Haskell, only one module can be per file. And then to import something is pretty easy. So import data list. And if you want particular things, if I want that zip, it's just a dependency, so I can name them all out. There's also a way to import qualify, which is kind of like, I think C# does this. It has L, and then everywhere where I want to do zip, do L.zip instead. Error handling, you have, okay, so in error handling, there are like, just error, which does throw an exception. But not many things actually use that. That's like the really like ugly warts, like fatal things where that happens. For everything else, there's the maybe type, which is like it's called the option type. Right? You do just, except it calls it different names because I don't know why Scala names it differently. Just one, just like that. I do type just one. It returns me a maybe. Unlike in Scala where I do sum of one, it's type sum. That's because just is a function, not a type. And then none is nothing. And then there's some functions for those guys too. There's also a whole bunch of other cat maybes from just. Those are all under the data maybe. So maybes. There's also an either, which is exactly, not exactly, but it's close. where it's a left or right, which is on the Scala. Except in Haskell, it's actually all right biased, which is great. But don't worry about that. All right, so you guys really want to cover monads? Not really? How many of you know what a monad is?
I know the category of functions.
True. Anybody else know what you guys all know what monads are? They're burritos, yeah. They're containers, whatever you call it. I mean, all they are. So we really really overthink what monads are, just because they have a weird name, I think. And maybe because, but really, I mean, all a monad is just this one operation, where given an n of something has something, right? Some context or some container. Given another function that takes in that thing that I'm containing and returns me that same type of container type thing, but with a different thing inside of it, I can return that back. So I open it more or less, give it access to my guts, and I can transform into that other one. That's all it is. There's returning this fill. Don't look at this. That's something that Haskell has due to like old historical reasons. I'm not going to go into. There's also this thing here that says I don't really even care about the inside of it. Just open and shut it. And return this instead. There's a return that says I'm going to give you something, and you're going to lift it up inside of that container, just like put it in there. In true math, monads are applicatives, and applicatives are a lot simpler than monads. And I kind of, in Haskell, the next version, there's this big push to actually fix the rungs of monad not inheriting from applicative, which means that all monads have to be applicatives. And this is going to change a lot of different code in Haskell to be not so monad biased, but instead be more based on applicatives. And applicatives are a lot simpler to look at, I think. It doesn't have nearly as scary of a name. Basically, let me find it. This is the one I'm really looking for, the lift A2. This is the way I think about all applicatives. Given I have two containers, right? And then I have some function that takes the inner type of those two things, I can smush those together and transform into that to give you a new one. That's all it really is. Smushing things together. And we don't have it here. I used to kind of think of it as like I have two things, I can smush them together and inside get a pair, this is just a generalization of that. My function is just pairing them together. So that's what applicative sort of mean. I don't know. Anybody else want to use applicatives? They're gonna make it in Haskell, so it's a lot of code will just vanish. Because what ends up happening is everybody who has an instance of a monad also has an instance of applicative as well too. That's the rules of the road. I/O. So now that I've kind of talked about monads a bit, when you do something like you notice we haven't told it like there's no hello world, right? We haven't shown any hello world, and I mean this is the hello world. Let me do this. See, it actually did it. But if I was to put that in my script, it wouldn't actually execute it. I wouldn't actually get hello world printed out. And this is because this is because instead of actually, this is the pure part of Haskell. Like if you go all the way back, it's like Haskell's pure. What it does instead is it returns me an IO monad, which means it defers off the actual execution of that to later. These the parentheses means unit, which means like void. It doesn't. It's nothing. But it's an IO of unit. So this is doing nothing, but it's returning me an IO. So sooner or later, let's do let x equals. Let x equals that. And we do my type of x. Still hasn't printed anything out. My type of x is still an IO. In GHCI, it'll automatically just evaluate all IOs. What ends up happening in Haskell is that there's only one place you really should be doing it. Like, it should actually evaluate the IO. It's this function main that automatically calls an executable. Other than like that, you should never be executing IO. There are some things that kind of like sidestep it. So there's like an unsafe perform IO. You actually have to import underneath the unsafe module. But if we do X, then prints. Just keep it prints over and over again. So that's cool. View syntax, kind of like the four comprehensions, but really like basis is on monads. You guys are probably feeling kind of drained. I don't want to know what type of speed. Functors, applicatives, monads, semigroups, monoids, monoplus. These are all good things. But they're all as you keep on going. This is the newest thing that this is the new hotness in the FP world. These comonads. But the way where I learned most of the FP and Scala book really kind of introduced me to a lot of these. A lot of these cyclopedia stuff, where you learn about monads, semigroups, monoids. Monad plus it doesn't cover because it's like a filterable monoidy monad. Yeah, that's it. And then foldable is just like something, and you can something bigger, not necessarily bigger, and it can all be struck down into one value. Traversable, it's like I got something that I can where I can traversable. I don't know, just look at the docs. Just kidding. Category is a just find these. There's a whole big Wikipedia page that they put all these in. Where it was all the way back. There used to be like a Haskell newsletter called the Monad Reader, but now it's kind of died out. But now it's like this gigantic wiki called the Haskell Wiki. It's a really good read if you really like start to learn Haskell and you got like a good month to kill. Learning all this stuff is really like this cyclopedia has made me a better programmer, I think. Especially thinking about functors and everything else. Okay, so all right, using Haskell, just some tips. Use GHC. There's a couple others out there. Don't even look at them. They're all abandoned. There's Hugs, just like this old academic version. GHC is the hotness. It's like where everything's at. The Haskell platform I kind of talked about. A little bit stagnant. Well, it's not stagnant. It's just lags behind everything else. GCI is awesome. Like it has all these different things it can do, and they actually all work. And it's not weird. If I had my Emacs set up here, I can show you how I interact with the GHCI. It's kind of like in Clojure, you have a REPL, and you send commands to it all back and forth. In Haskell, you do the same thing. But really, I use GHCI in that context of, okay, number one, this is my code all type check, which is great. But then pulling out what is or different type signatures of different things, and it just automatically just like tell me right away. It's kind of cool. Good coding style. Avoid too many parentheses. That little $ trick I showed you before. Use that. One thing I didn't show you is like function composition. So this is a way of adding one to it, right? Let's say I wanted to add two to something. So, but I only have this add one function. So what I can say is, this is why I read things from right to left in Haskell. Add one, and then add one. This is a way of doing function composition. Basically means given a function from B to C and another function from A to B, so I can go from A to B and B to C, and I can take in an A and give you a C. I read this from right to left. It's like, I don't really care about too much about this, but like A to B, then I take B to C, then I can take an A. It's just fun composing those things together. I kind of talk about point create a little bit. Package is awesome. Haskell has the prettiest documentation I think I've ever seen. It's a really low bar in a lot of different languages. But like this data list here, it gives you, everything is very well documented. And one thing I was going to show you guys on my on my Emacs, but I can't. There's this thing called doc test. How many of you have ever heard of Python doc test or doc test? Well, so we're used to writing tests, but we're used to writing tests outside of the actual implementation of it, right? And then we're always saying, oh, we don't really want to comment code or anything like that because my code should be the documentation for it, right? My test examples really are the documentation of how things really work. And what doc test is like, yeah, we'll just make that happen. You put your test in your comment above it, and then executes that. So you say, examples, fib of 10 is 55, fib of 5 is 5, and then your actual implementation of that. They live right together. The cool thing about package, or thing that makes the docs, is that it'll still, I can't find a good example. Maybe. Maybe this is right. This actually, yeah, these examples down here, those are actually our code, and it actually puts those in there as our actual documentation. For instance, beautiful docs out of that, and anything else you want to explain about it, you can too. Anyways, package is awesome. It's really, really great. Other things, Google's really cool. Like, if Google's like, there's got to be something out there that does this. You're thinking to yourself, like, you're coding, like, let's say I forgot what math is, right? But I know there's something out there that like takes a list of A's and then some function from A to B. Even then, I'm doing my arguments out of order, right? And then gives me a list of B's back, right? But and then it takes the signatures and looks at other signatures of everything that's a package, and looks at those and like, oh, Matt, this is kind of what you wanted, right? This is first. It's really, really freaking slick. Well, I'm going to say maybe. Oh, here's maybe right there. You can look at any like monad reader. And it automatically links straight to package. Really cool. That's built in, like, this has saved me so much time in my life. There's nothing like it for Scala or anything like that. and it's just kind of built into. I have like, I think that the Haskell package for Emacs just has a Google function. You just say Google, and whatever you're trying to do, and just finds it's great. Other little things, Cabal. I'm not gonna really. Cabal's the build tool in Haskell. Um, in Haskell, GHC itself takes care of where things, its own package management, but nothing tells it how to get to from anywhere to your machine. And that's what Cabal does. It figures out the dependencies of everything and pulls those down. And it also builds your thing too. And it can push things up to package or wherever, like we have SPT or Maven. It also has this concept of, there used to be this thing in Haskell called dependency hell, or Cabal hell, where you have conflicting versions. Like by default, GHC just has one giant global index of, kind of like in Ruby gems, where you have one big giant Ruby gem thing. And Bundler came along and fixed all those things. That's what Cabal Sandbox does. Makes a little sandbox of just your project dependencies and puts it in a special location where it can't touch anything else and nothing else can touch it. And it just works. The Cabal's come a long way since I started to. Running this, I'm not going to worry about this. Normal structure. Let's go back to this guy. Normal structure application. Source goes under here. Really dumb. And then all your modules start from here, like with the root level, just kind of like earlier in Java anyway. The way modules are laid out is a little bit different than what I'm used to in the past. Let's go to like, oops. JSON's a JSON library, but you think, coming from other programming languages, that its package name would be ASON. It is. Damn it, that's not a good example. I can't remember. What I was trying to get at is like the packages modules aren't like necessarily what the actual package names are. Maybe the another good one now. NTL. Like they're not like MTL about something. They're like meant to be part of like, where would you find a modad reader, right? There'd be a control modad, that reader. It doesn't really try to make anything obtuse. You don't have to think, oh, this comes from the MTL library. So that's something to keep in mind. Yeah, I'm not going to go there. So I got a whole bunch of links on these two. Like ASON for JSON, MTL for like, it's called a one transformer. This is the beginning Haskell. You shouldn't even worry about this stuff. Types, web frameworks. There's a couple of them. There's the ASOT, there's Snap, they're all pretty up to snuff, and really there's no like stinkers in all of them. Persistence for persistent. Anyways, more resources like Package, Google, Learn Haskell. This one's really great. We're just talking about it in our Haskell head chat room. For like installing Ubuntu, like there's courses to take. There's a lot of great resources there. Yeah, a whole bunch of different lectures. And yeah. Anyways, is there any questions about Haskell? Just blow your mind? See, the thing about it, I always find is like Haskell has this reputation of being a really difficult language, and there's a lot of really smart people working on it. That's part of the perception problems. But when it comes down to it, it's like just plugging things together. It works. just really works really well. So, yeah, Facebook is starting to use it internally for their actual, so their bigger projects. They actually hired 2 of the really smart guys that used to work on Haskell, and they started to use it for their internal analytics pipelines, different things, like worrying about spam detection and stuff like that, really. But yeah, they have this thing built on. It was applicatives I was talking about earlier. Like, I got 2 different sources, and I don't really care about when they come through. I just know I need them, and handles caching and all this other cool stuff. It's kind of hard problems to figure out. But. All right, that's all I got, guys. Hopefully, go forth and write Haskell. But really, like, there's just a whole bunch of good resources to go learn. It's just been a great experience to learn Haskell. So I'm still learning Haskell. Cool. All right. Thanks.